Okay, students, today our topic is IZOD impact test. As we know already that the tensile and hardness tests are used to determine the static characteristics of the material. The loads are usually applied slowly so that the test piece may be considered to be in equilibrium and with the load with the load at all times. Such static tests do not predict the behavior of the material when parts are subjected to rapidly changing or reversing stresses and to sudden stress and shock. The tensile tests do not always reveal the susceptibility of a metal to brittle fracture. This important factor is determined by the impact test. An ordinary test cannot be applied with sufficient rapidity because of the inertia of the parts of the machine. For such rapid stresses, the test is called impact test. All forms of impact test depend upon a swinging pendulum. You can see the swinging pendulum here also. This is the swinging pendulum. So, the height from which it drops, is a measure of its inertia at lowest point. There it collides with the specimen. The specimen is kept generally here. Here it collides with the specimen, breaking it, and continues onward to its swing. That means it will swing here and it will break the specimen here, and the pendulum will continue swinging. And the difference between the height and the height to which it would have risen had no specimen in present is the measure of the energy required to break the specimen. This is expressed in cm/kg. It is the impact value of the specimen. The high impact value indicates better ability to withstand shock than a low impact value. For most ferrous metals and for all those softer metals, the test bar has a notch or groove cut across the tension side. Let me show you the test bar. Yes, this is the notch or groove. This locates the point of fracture and gives lower results than would be obtained on an unnotched fracture. And the effect of the notch is so great that much care and accuracy is necessary in cutting it. The main purpose of the notched bar tests is to study the simultaneous effect of the stress concentration and high velocity load application. In impact tests, the fracture may be either brittle or ductile. The brittle fracture is not accompanied by noticeable plastic deformation. This type of fracture will have bright granular or crystalline appearance. On the other hand, considerable plastic deformation takes place in a ductile fracture. The fracture surface will have a dull gray fibrous appearance, many times a mixed fractures with which both crystalline and fibrous areas are observed. There are two commonly used types of impact test machines, namely the CHARPY and the IZOD. I have discussed CHARPY impact test in my other slide. Here I will discuss about the IZOD impact test. Here we can see that the brittle fracture may result due to the presence of any of the combination of these factors in sufficient magnitude. As triaxial state of stress which exists at the tip of the defects in the component and low service temperatures are mostly responsible for the brittle fracture. These effects become more pronounced at higher rates of loading. Therefore, the susceptibility of the materials for brittle failures under the existence of these factors is determined by the tests which apply first loads like impact loads. The triaxial state of stress is developed at the root of the notch, and hence notch specimen are used in impact test. I have already shown you the specimen here already. The sharpness of the notch is largely controls the test, but geometrically similar notches do not produce the same results on large parts as they do not do on small test specimen. Consequently, the behavior of the material under unmeasurable triaxial tension in service can only be obtained by testing full-sized parts in that will be stressed in service. Now, this is the theory related it, and the procedure of IZOD test is the latching tube for IZOD test to be firmly clamped. Also, let me tell you something about IZOD test. The test consists of breaking by one below of the swinging hammer, the notched test piece gripped vertically with the bottom of the notch in the same plane as the upper face of the grip. The blow is struck at the fixed position on the face having the notch. So adjust the pointer, then with the pointer carries 168 joules readings on the dial. The specimen of the IZOD test is firmly clamped on the support with the help of clamping screw or skating gauge. This is briefly the picture of the test. This is the hammer which strikes the vertically placed IZOD specimen, the notch facing the hammer, and breaks it, and from which this 168 joules we get a reading on this specimen on this dial gauge, and we check that whether the fracture is ductile or brittle or a mixed fracture. So this is how toughness is determined. The toughness is initial energy of the pendulum minus swing energy of the pendulum. So an impact test is a dynamic test in which standardized test specimen is struck and broken by a pendulum or hammer in a specially designed testing machine, and the energy absorbed in breaking the specimen is measured. So this is the part of the IZOD testing, and please study well. And here it is, my lecture ends here, and thank you and stay well.